All right, let's dive into a really interesting problem. This is a 5-mark question from the GCSE higher tier non-calculator maths paper, and it's a great one. It's got circles, it's got straight lines, and it has a fantastic little twist at the end that shows you a lot about how these exams actually work.
So here's the setup. You've got a circle right at the origin and a straight line that slices through it at 2 points, P and Q. We're given a bunch of coordinates and we're told the line has a positive gradient. The mission is to find the value of K, which is just the y-intercept. Now 5 marks are up for grabs here, so the big question is, how do you make sure you bag every single one?
Well, the absolute best way to guarantee you get full marks is to learn to think like an examiner. So that's exactly what we're going to do. We are going to follow the official mark scheme, step by step, and see precisely where each point comes from.
Okay, first things first. With any complex problem like this, you've got to break it down. Before you even think about doing any calculations, you need to pull out every single piece of information the question gives you. So let's list what we know for sure. We have a circle, center at 0, 0. We've got a line that hits it at P and Q. We have the full coordinates for P, 5, 10, but we only know the x-coordinate for Q, which is -2. And this is important, we're explicitly told the line has a positive gradient and it hits the y-axis at K. Our job? Find K.
Right, we've got all our facts lined up. Now we can start the real work, the hunt for those process marks. Let's use what we know to find the first few pieces of this puzzle.
And what does the mark scheme say first? Right here, it's crystal clear. The very first mark, a process mark, is for finding the equation of the circle itself. This is our way in.
So how do we get it? Well, since the circle's center is at the origin, its equation is going to be x squared plus y squared equals r squared. We know the point P, 5, 10, is on that circle, so we can just pop those values in. 5 squared is 25, 10 squared is 100, add them up and you get 125. So the equation for our circle is x squared plus y squared equals 125. Boom! First mark in the bag.
All right, moving on. The mark scheme says the second process mark comes from using our brand new circle equation to hunt down the y-coordinate of our other point Q.
We know the x-coordinate of Q is -2, so let's plug that into the equation. -2 squared is 4. Take that away from 125, and you get y squared equals 121. Now, and this is super important, when you take the square root of 121, you get 2 possible answers, +11 and -11.
Okay, now this part is really interesting. To get the third mark, the scheme says you must select y equals 11, and you have to give a reason. And the suggested reason? That positive gradient clue from the original question? Let's lock that in for now and just see where this takes us.
So we're following the mark scheme to the letter. We select y equals 11. That means we now have the full coordinates for point Q. It's at -2, 11. We now have 2 complete points that we know are on our line L. P is at 5, 10, and Q is at -2, 11.
Now that we have 2 points, we're in a great spot. In fact, the mark scheme actually gives us 2 different equally valid ways to find K from here. Let's check out path number 1, the gradient method.
So here's what the mark scheme says to do for the fourth process mark. We need to calculate the gradient between our 2 points, P and Q, and then substitute one of those points into the good old line equation y equals mx plus k to find our answer.
So let's do the math. The change in y is 11 minus 10. That's 1. The change in x is -2 minus 5. That's -7. So hang on a second. That gives us a gradient of -1/7. But didn't the question say it was a positive gradient? That's our first big red flag that something a bit weird is going on here. But look, we're just following the process. We substitute that into y equals mx plus k, do a bit of rearranging, and we get k equals 75/7.
But hey, what if you didn't think of the gradient method first? No problem at all. The mark scheme has an alternative path that's just as valid, using simultaneous equations.
This approach also gets you that same fourth process mark. All you do is create 2 linear equations, one using the coordinates of P and one using Q, and then you solve them together.
Let's walk through it. Point P gives us 10 equals 5m plus k. Point Q gives us 11 equals -2m plus k. Now if we subtract the first from the second, the k's cancel out beautifully, leaving us with 1 equals -7m. So the gradient m is again -1/7. And when we plug that back into the first equation, yep, we find k is 75/7. Both methods give the exact same answer.
So, we have shown our working. We've followed the process marks perfectly, we've even used 2 different methods and got the exact same result. So what is that final 5th mark actually awarded for?
Take a second to think about it. Based on all our step-by-step logical working, what should that final answer for K be?
And here it is, the big twist. Our meticulous working, following the first 4 process marks exactly as written, leads us to K equals 75/7. But the mark scheme awards the final accuracy mark for a completely different answer. K equals 4. This is the final line from the mark scheme. A1 KO for K equals 4. The A stands for an accuracy mark, but the cow is the crucial bit. It means correct answer only. What this almost certainly tells us is that there was an error in the original question. While all the process marks correctly follow from the flawed information that was given, the intended answer was K equals 4. It's a very, very unusual situation to see laid out so clearly.
So that leaves us with a fascinating question for any student. In a situation like this, where the logic of your process leads to one answer, but the correct answer is something else entirely because of a mistake, what really matters more? Is it about showing you can follow the mathematical steps, or is it about getting that one specific number at the end? It's definitely something to think about when you're preparing for these exams.